Yes, hello viewers, you are most welcome to the eMath learning platform once again. I am now going to still take you through pure mathematics and specifically on our topic called integration. This tutorial is going to be a continuation of our previous tutorial that was about the introduction to integrals of trigonometrical functions. Now, without wasting a lot of time, I will begin with examples about integrals of trigonometrical functions. Let's look at this question here. It says find the following integrals. Part A, integral of sine 2x with respect to x. Part B, integral of cos 3x with respect to x. Part C, integral of sec squared 2x with respect to x. Part D, integral of sec 3x tan 3x. Part E, integral of cos sec squared for x with respect to x. Part F, integral of cosec 2x cot 2x with respect to x. We are going to begin with these 6 examples, and this will guide us through on how to progress with other parts of this topic as we move on. Now, before we do anything about this, we need to first recall from the previous tutorial that we said and concluded that integral of sine x with respect to x is negative cos x plus a constant. Integral of cos x is positive sine x plus a constant. We also said that the integral of sec squared x with respect to x is equals to tan x. We also said integral of sec x tan x with respect to x is equals to sec x plus a constant. We also talked about integral of cos x squared of x with respect to x being negative cot x. We also said that the integral of cosec x cot x is the same as negative cosec x plus our constant of integration. Now, having known all this, we are now going to apply this knowledge here. Because we already have this all, we should have made them part of us. We are now going to look at what happens with different formats of these very trigonometrical functions. So having looked at all this plus the previous ones, we can now say that we can now do our question that we have there. So without wasting a lot of time, part A of our question was talking about integral of sine of 2x with respect to x. Now I want us to find out and ask ourselves, yes, if the integral of sine x with respect to x is negative cos x, do we think that the integral of sine 2x with respect to x will also be the negative cos of 2x? That is a question for us to address. Ideally, when you look at this, the answers will not be perfectly the same as we are saying. But we shall first realize that the difference between this integral here, with sine of x is that for sine of x, the coefficient of the angle or the coefficient of x is 1. But for sine of 2x, we have a coefficient which is 2. So it means in such a case, what we do, we begin by letting. So we let u to be our angle. So our main target is going to be the angle, which angle in this case is 2x. So we let u to be 2x. Now, if u is 2x, we go on and differentiate. That means we shall be looking for the u dx. Automatically, when you differentiate to x, you get 2. When you differentiate to x with respect to x, you get 2. Now that we have du dx as 2, we simply make the x the subject. So the x becomes du divided by 2. Now after realizing that our dx is du divided by 2, we shall now have the whole of this integral here. Shall have the whole of that integral here, which is sine integral of sine 2x dx, giving us integral of sine u du over 2. Now, what has happened here? What has happened here is basically this. The 2x, we already called it to be u. That is why I have sine u now. The dx, we already made it the subject here, and we came up with du out of 2. And that is why we have du out of 2 at this point. Now, this expression, as you look at it, there is a constant, which is a half. That a half, being a constant, is very, very free to come out of the integral sign. So it means our next step will be having the a half come out of our integral sign. So it means we shall have a half integral of sine u with respect to u. Now that we have sine u with respect to u, it is not different from having sine x with respect to x. But we know that integral of sine x with respect to x is negative cos x. If that is true, then it means even in this case, integral of sine u with respect to u is going to be negative cos of u. So it means at the end of it all, we shall have negative a half cos of u plus a constant. Negative a half cos of u plus a constant of integration. But remember, our u was called 2x. So it means in our conclusion, we shall say sine of 2x with respect to x is equals negative a half cos of 2x plus a constant. What has happened here? What has basically happened is that our u has been substituted as 2x. So it means whenever you integrate sine of 2x with respect to x, you get negative a half cos of 2x plus a constant. Now, to give you some simple logic, because this can also be done directly, and we shall indeed do this directly as we move on with more tutorials. Looking at this integral here and looking at our function, look at the angle. The angle is 2x. When you differentiate 2x, you get 2. I'm going to give you a shortcut of how to find this answer without going through all the steps we have gone through. That is, if it just comes out of part of a given question, as we shall look at it ahead. So I differentiate the angle, which gives me 2. Now I integrate sine. When I integrate sine, I get negative cos. So that is why I have negative cos of 2x, but I don't forget to divide by the 2. Dividing by the 2 is as good as multiplying by a half. And that is why we come up with our integral of sine 2x with respect to x as negative a half cos of 2x plus a constant. Okay, let's move on to part B of our question. Part B, they had given us integral of cos of 3x with respect to x. Now again, even before we do anything here, you can predict what the answer will be. Look at the angle that we have. Our angle is 3x. So when you differentiate 3x, what do you get? If you differentiate 3x with respect to x, you get 3. So it means we expect the answer to be the integral of cos, which is positive sine of 3x, but divided by 3. Where are we getting the 3? The 3 is the derivative of the angle in this case. When you do that, you will come up with a third sine of 3x plus a constant of integration, because we don't have limits yet. But for now, we shall go through all our procedures as we have started. So let's say let u be 3x. I differentiate. So that means du dx is equals to 3. If du dx is equals to 3, I make dx the subject. So you can first cross multiply, then divide both sides by 3. So it means I'll have dx as du out of 3. Now that dx is du out of 3, I can go on and say our integral of cos 3x dx is equals to integral of cos of u du out of 3. And what has happened here is that we have replaced the 3x with u because we called 3x to be u. We have replaced dx with the du out of 3 because we made dx the subject at this level here. Because we made dx the subject at that level. So when you do this, then you come up with this. Again, we realize here we have a third, which is the constant. So it can come out of the integral sign, so that we have a third integral of cos u with respect to u. So that is where we expect to move to. So it means we shall have a third integral of cos of u with respect to u. But remember, again, from our first tutorial, we said integral of sine x, of cos x, is equals to positive sine x. That means integral of cos u with respect to u will also be positive sine u with respect to u. Meaning we shall have a third sine of u plus a constant of integration. But remember, you have to substitute back for the value of u in terms of x. And remember, we called the u to be 3x. So we can conclude and say integral of cos 3x dx is equals to a third sine of 3x plus our constant of integration. So you can realize that we had already predicted this answer right from the beginning by simply knowing the shortcut, which says get the angle, which is 3x, differentiate the 3x, you'll get 3. Integrate cos, you get sine. So after getting sine of 3x, divide it by 3. But dividing by 3 is as good as multiplying by a third. So that is how easy our working would be. Let's move on to part C. We have integral of sec squared of 2x. Can we try to predict this again? We need to recall that we said integral of sec squared x is equals to tan x. That is from our first tutorial. Now, if integral of sec squared x is tan x, what are we going to do to get integral of sec squared of 2x? Now, what we do, get the 2x, differentiate it, you get 2. That is if you differentiate with respect to x. Now, the 2 you obtain, you now say, if I integrate sec squared, what do I get? I get tan. So we expect the answer to be tan of 2x but divided by 2. Tan of 2x divided by 2, or you can say a half tan of 2x, and that will be our answer. Let's look through the procedures. So we shall say solution. Let u equal to 2x, which is our angle. Du dx will be 2 when you differentiate 2x. Make dx the subject. It becomes du out of 2. Come up with the whole of this integral, which is now integral of sec squared of 2x dx, becoming integral of sec squared of u with respect to x. Of u with respect to u, but this time around the du is divided by 2. Why? Because our dx, as you see it here, was already du out of 2. Our 2x, as we see it here, was u. So I've substituted for 2x as u and the x as du out of 2. When you look at this again, you are going to realize we have a constant, which is a half, and can come out of the integral sign. When it comes out of the integral sign, we shall have a half integral of sec squared of u with respect to u, which gives us a half tan of u. Just because we know when you integrate sec squared of u with respect to u, you get tan of u plus a constant. So whenever you get challenges with these integrals, they are even captured within the mathematical tables. That is basing on the UNEB mathematical books or booklets that we always have. Okay, so we can conclude and say integral of sec squared of 2x with respect to x is going to be a half tan of 2x plus a constant, and that becomes our answer. We can move on to the next one. So I can say integral of sec 3x tan 3x dx. So what do you realize here? So when you look at this, you go back to integral of sec x tan x. Remember we said integral of sec x tan x in the previous tutorial was simply sec x. That means if the integral that now we have is sec 3x and tan 3x, then it means our angle is still 3x. We differentiate the angle with respect to x, we get 3. So it means our answer is expected to be a third of sec 3x. But again, we shall go through our procedures normally. So u will be 3x, differentiate, get du dx, that is 3. After getting du dx, make dx the subject, that is du out of 3. Come back and now look at your your integral. The whole of this integral now is going to be the same as, the whole of that integral is going to be the same as sec of u tan of u du out of 3. What has happened is that we have simply substituted for 3x as u, as you can see. Now we have sec u tan u. And we have also substituted for dx as du over 3. That is why I have du out of 3 here. So when you do this again, you realize that a third is a constant. It can come out of the integral sign. So when it comes out of the integral sign, we shall have a third integral of sec u tan u with respect to u. But when you integrate sec u tan u with respect to u, you expect to get sec u. So it means our answer will be a third sec u plus a constant. Conclusion, we have to substitute for our u. Remember, our u at the beginning was 3x. So it means at the end of the day, we shall say the integral of sec 3x tan 3x with respect to x is a third sec of 3x, but plus a constant of integration. So with that, we can also say that is the solution for that. Next question, we have integral of cos x squared of 4x with respect to x. Now recall again from the beginning, or in our previous tutorial, we said when you integrate cos x squared of x with respect to x, you get negative cot x. What about when you integrate cos x squared of 4x? What shall we do? We shall differentiate the angle, shall get a 4. When you integrate cos x squared, you get negative cot. So we expect the answer to be negative a quarter cot of 4x plus a constant. Let's look at the procedures again. So the procedures are going to be as follows. We are letting u to be 4x. Please, you should be asking why I have used u almost in every question. It is just a letter that I prefer using. You can use any other variable. You can use p, you can use r, or any other variable of your choice. But for me, I prefer using u. So u is 4x. That means du dx is going to be 4. I make dx the subject, it becomes du out of 4. After making dx the subject, I now get back to my integral, this one here, and it becomes integral of cos x squared of 4x dx is equals to integral of cos x squared u du out of 4. What has happened again? What has happened is that the 4x has been substituted by u. The dx, which we already had at this level here, became du out of 4. A quarter is again a constant. It can come out of the integral sign. When it does so, we shall have a quarter integral of cos x squared of u with respect to u. When you do that, of course, the integral of cos x squared of u is negative cot of u. So our answer will be negative a quarter cot of u plus a constant. But we have to substitute for our u. So it means integral of cos x squared of 4x with respect to x is equals to negative a quarter cot of 4x plus a constant. Cot of 4x plus a constant. So we can now move on almost to the last example here, and that is going to be integral of cosec 2x cot 2x dx. This reminds us about the integral of cosec x cot x, which was supposed to be, which is negative cosec of x plus a constant of integration. That means in this case, our angle is 2x. Differentiate the 2x, you'll get 2, meaning the answer we suspect, or the answer we expect, is supposed to be negative a half but cosec of 2x. But let us go to the main procedures as usual. So we let u to be 2x, differentiate, you get the u dx as 2. Make dx the subject, you get the u out of 2. Get back to your integral, our cosec of 2x cot 2x dx, and our integral will be integral of cosec u cot u du dx. I have again made the substitution of 2x as u, as you see, then dx, we have it here, and I've called it du out of 2. So a half can again come out, and when a half comes out, we can have a half integral of cosec u cot u with respect to u. When you integrate this, we expect to get negative cosec of u. So it means we shall have negative a half cosec of u plus a constant. But u must be substituted back in terms of x. So it means at the end of the day, we shall have integral of cosec 2x cot 2x with respect to x equals to negative a half cosec of x. This is supposed to be cosec of 2x. I just beg your pardon here. Okay, so that is it. So from that point, we can now be sure that that is our solution.